This is a graph which represents the path a ball will travel if it's thrown at u meters per second at an angle of theta. Now we can model the horizontal displacement of the ball by using distance equals speed times time, where x is the horizontal displacement, u cos theta is the horizontal component of speed, and t is time. Also, we can model the ball in the vertical plane by using the Suvac equation, s equals ut plus a half at squared, where s is the displacement, u is the initial speed, t is time, a is acceleration, and t is time again. Now we can use this equation because gravity is constant, and we can use the Suvac equation for constant acceleration problems. Now we have replaced s with y because it's the vertical displacement, u sine theta with u because it's the vertical component of speed. We've kept t and t here, and instead of writing a, we've got minus g. G is 9.8, which is the value of the acceleration due to gravity on Earth. The reason why it's negative is because it's in the opposite direction to the positive vertical displacement, y. Now we have these two equations, equation 1 and equation 2. We can rearrange equation 1 to make t the subject, and so then we can eliminate t. Here, this is equation 1, where we've divided by u cos theta on both sides, so t is the subject. Now we can substitute this expression here into equation 2 and put x over u cos theta wherever we had t before. This gives us u sine theta times x over u cos theta minus g over 2 x over u cos theta all squared. Now we notice that the u's here can cancel, and also the sine divided by cos is equal to tan. Now, why is this relevant? Well, we know that if this equation models the path of the ball, and the ball is moving over a house with these dimensions, these 3 points need to be cleared in order for the ball to actually go over the house. Now, we can write this mathematically using these 3 inequalities, where the heights and the x1s, the heights and the displacements, are all corresponding to these 3 points. We can set values for h1, h2, h3, x1, x2, x3, u and theta to see if we can find a solution to the problem. If these 3 inequalities are satisfied with the values for the unknowns, then it means that we can throw the ball over a house.
So now let's sub in some values. So for u we have 26 meters per second, and then theta is 80, and our initial x is 15. And then we've used an average height of a house, so therefore we get other values as well, x2 and x3. So for h1, when you sub in all the values, then it does satisfy the equation. That 6.2 is less than or equals 30.98. And the same with h2, and the same with h3, which means that the ball will go over the house. So, and then we're left, now we want to see how far it travels in total. So we put y equals to 0 when using this equation to find the total distance. And that means that in total, the ball travels 23.63 metres. And then we can find out the time of this. So it takes 5.23 seconds to go that total distance, which means that someone needs to be running at a speed of 4.52 metres per second, which is pretty doable. So he means he can throw it, and it will take 5.23 seconds, and he needs to run 23.63 metres to catch it.